everyone, welcome back. You know how much we love digging into the stuff you send us. And this time we've got a really cool one.
Oh, yeah, this is going to be good.
You sent us this NASA article. It's, let me see, published just yesterday, December 12th, 2024.
Hot off the presses.
And get this, the title is Astronauts Launch Bold Experiments and Gear Up for Critical Spacewalk. I mean, come on, how cool is that? And it's all happening like 272 miles above us right now, up on the ISS.
The International Space Station. Always buzzing with activity.
All right, so where do we even begin with this? It looks like they're launching some sort of experiment called the Euromaterials Aging Experiment.
EM.
Right, EMA. But, like, what's the point? Why are they just chucking materials out into space?
Well, think of it this way. Space, it's not exactly a friendly environment, is it? You've got extreme temperatures, radiation, the occasional micrometeoroid zipping around. It can really do a number on even the toughest stuff.
Okay, so they're basically torturing these materials.
Kind of. The EMA, it's going to be exposed to all that for a whole year. We're talking serious stress testing here.
A whole year. I guess that makes more sense than just saying, oh, we're testing materials. But hold on, the article mentions the Canadarm2. That's the robotic arm, right? The one that, like, grabs onto spacecraft?
That's the one. A real workhorse. It moves stuff around, helps astronauts during spacewalks, can even snag an approaching spacecraft. A multitasker for sure.
So in this case, it's gonna, like, move this experiment from the Bishop airlock.
Which, as you know, is how they get things in and out of the station.
Right. And then install it on Bartolomeo.
A platform outside the European Columbus module. They've got it all mapped out.
So they leave this thing out there for a year, gets beaten up by space, and then they bring it back in. What happens then? Like, what's the big reveal?
It's all about the data. Imagine we want to build a moon base, or send people to Mars, for that matter. You wouldn't want to build those out of materials that crumble after a couple of years, would you?
No, definitely not. So this is like laying the groundwork for those missions.
Exactly. Spacecraft, habitats, spacesuits. The EMA will tell us what holds up and what doesn't. It's crucial stuff.
Okay, now that is pretty cool. We're not just talking about some random science project. We're talking about, like, the future of humanity in space.
The big picture stuff.
But speaking of humans in space, the article also talks about this NASA flight engineer, Nick Hague. He's doing research on the immune system, like how it works in space.
Oh, yeah, Nick Hague. His work is fascinating. He's trying to figure out how spaceflight, especially long-duration missions, affect our ability to fight off infections.
But how do they even study that up there? It's not like they have a hospital on the ISS, do they?
No, but they've got a pretty impressive research lab.
Really?
You've got it all. Harmony, this is a module where they do a lot of the research. Cubic incubators for growing cells. Centrifuges, freezers. It's high-tech stuff.
That's wild, but why not just do all this research on Earth? Wouldn't it be easier?
Because space changes things.
Yeah.
You've got microgravity. That's the near weightlessness they experience up there.
I've seen videos of astronauts floating around. Looks fun.
It's not just fun and games. Microgravity, it affects our bodies in ways we're still trying to understand. Cells, fluids, everything reacts differently. That's why we need to study this stuff in space to see how it really works.
So what they learn up there, it could help us down here too.
Exactly. New treatments for immune problems, ways to keep astronauts healthy on long missions. It all ties together.
Okay, I am seriously impressed. And just when I thought this deep dive couldn't get any cooler, the title did mention spacewalks. I'm guessing that's where things are headed next.
You bet. Spacewalks coming right up. And they're a lot more involved than you might think.
Well, yeah, I always kind of imagine them just floating around, taking in the view, like space sightseeing.
Not quite. These cosmonauts, Alexei Ovchinin and Ivan Wagner, they've got a pretty serious task on their hands, moving some essential equipment.
The article mentions science and robotics hardware. Sounds like a delicate operation.
You got it. Every move has to be carefully planned, choreographed even. Think of it as zero-gravity ballet, but with, really important tools.
High-stakes ballet. I like it. And they're practicing for the Poisk airlock. Is that a specific spot on the station?
The Poisk module. Yeah, it's basically their doorway to space.
Yeah.
The Russian segment of the station.
Right. So they put on their spacesuits there and head out.
Those Orlan spacesuits, they're incredible pieces of technology. Like a personal spacecraft, really.
Speaking of, I've always wondered about those spacesuits. How do they, keep a human alive out there?
Oxygen, temperature control, protection from micrometeoroids and radiation. It's all built in.
It's like they're wearing their own little life support system.
Exactly. And don't forget, the article mentioned cosmonaut Alexander Gorbunov overseeing the airlock process, depressurization and repressurization.
That sounds intense.
It is. They have to gradually lower the pressure in the airlock to match the vacuum of space, then carefully bring it back up when the cosmonauts return.
You know, all this talk about spacewalks got me thinking, it's not just a solo mission up there, right? The article mentioned communication tests, like how crews from different countries work together.
You're right. The ISS is a truly international effort.
Which I guess makes communication even more important.
Absolutely. Imagine coordinating a project where your team is spread across multiple countries, different languages, different cultures.
And you're relying on mission control, who knows how far away.
Throw in the fact that any miscommunication could have, well, serious consequences. That's why these tests are so important.
They have to make sure everyone is on the same page, literally, especially during something as critical as a spacewalk. But, you know, all this technical stuff is amazing, but I gotta admit, I'm kind of missing the visual side of things.
Well, remember those incredible images from the article?
Oh, yeah. Those were something else. That shot of the station taken from the SpaceX Dragon, just hanging there above the clouds over Patagonia.
Talk about a perspective shift.
It really puts things into perspective, doesn't it? This giant structure, a symbol of human ingenuity floating above our planet.
And then there was that image of the Cygnus cargo spacecraft, docked at the Unity module.
Packed with all those vital supplies, like a lifeline to the crew.
Food, water, equipment, spare parts. They rely on those cargo missions to keep everything running.
It's like a space version of Amazon Prime, but on a much grander scale.
But those photos, they also highlight how interconnected everything is up there, and the constant work that goes into keeping it all functioning. You know, aside from the immunity study, there's a whole range of other research happening on the ISS. The article mentioned a cardiac study.
Cardiac, like related to the heart.
Yep. Cosmonauts Ovchinin and Wagner, they're wearing electrodes and arm cuffs to track their heart activity and blood pressure.
So they're basically space cardiologists. But why focus on the heart? Is space travel hard on your ticker?
It's less about immediate danger and more about the long-term effects. Microgravity, it can mess with your cardiovascular system.
Changes in blood flow, blood pressure, all that.
Exactly. And when you're talking about long-duration missions, like a trip to Mars, those effects become even more important.
So they're studying this now to prepare for those future missions.
It's all about keeping astronauts healthy in the long run. But what they learn up there could also benefit us back here on Earth.
So it's a win-win. Space exploration leading to breakthroughs in healthcare. It's pretty amazing when you think about it.
And don't forget, even with all the hard work and research, the article did mention the NASA astronauts having some downtime.
Yeah, a half day off after their shifts. I guess even astronauts need a break.
Everyone needs to recharge, especially when you're living and working in such a demanding environment.
Makes sense. You can't be on all the time, not even in space. But, you know, taking a step back, what really sticks out to me is this theme of international collaboration.
Yeah.
It really does. You got to take care of yourself wherever you are. But I'm still kind of blown away by this whole international collaboration thing.
I know what you mean. It's pretty remarkable, isn't it?
The ISS, it's like, I don't even know, a symbol of what we can do when we all work together.
It's a testament to human ingenuity, right? You've got all these different countries, different cultures, all coming together to achieve something incredible.
Floating around up there doing all this amazing science.
And it's not just the astronauts and cosmonauts. Remember all those teams on the ground? Scientists, engineers, support staff all over the world.
It's like a global effort in the truest sense. I mean, just imagine the coordination involved.
Mind-boggling, right? Mission control centers all over the place, constantly communicating, making sure everything runs smoothly.
Makes you wonder, you know, if we can do all this in space, what could we do down here if we really put our minds to it?
That's the question, isn't it? Climate change, poverty, disease. These are global problems that need global solutions. Imagine if we could bring that same level of cooperation, that same drive to explore and innovate to tackling those issues.
It's almost like seeing those photos of Earth from space, it kind of reminds us that we're all in this together, down here on this little blue planet.
A powerful image, isn't it? But, you know, let's not get too philosophical here. Let's bring it back to the article. What does all this research actually mean for the future?
Good point. I mean, we've talked about the immunity studies, the cardiac research. All that has some pretty big implications for, well, everyone, right?
Right. New treatments.
Yeah.
A better understanding of how our bodies work. And don't forget that EMA experiment.
The materials testing. Yeah. What's the long-term impact of that?
Think about building habitats on the moon or sending people to Mars. You need materials that can last for decades, maybe even centuries.
That's where the EMA data comes in, designing the spacecraft and habitats of the future.
So we're not just looking at what's happening right now on the ISS, we're glimpsing into the future of space exploration.
Every experiment, every spacewalk, another step forward.
It's pretty exciting stuff.
Well, we certainly learned a lot today. I don't know about you, but I'm feeling pretty inspired.
Me too. Always a good reminder of what we're capable of when we work together.
So to wrap things up, what's the one big takeaway you hope listeners will remember from this deep dive?
I think it's the sense of wonder.
Yeah.
You know, the ISS, it's a testament to human ingenuity, to our desire to push boundaries, and to the power of international collaboration.
Nicely put. And it's a reminder that we're still exploring, still discovering, still reaching for the stars.
Never stop exploring, right?
Absolutely. Big thanks to you for joining us on this incredible journey. And to all of you listening, keep those questions coming, keep looking up at the night sky, and keep exploring. We'll see you next time.